Okay, a quick check-in on correlation, so a quick short video for you on this one. So correlation refers to the relationship between two variables. So you might get a question in the exam that says maybe you might have degrees centigrade up on one of the axes, and across here we might have number of ice creams sold. Okay, so we would have, in that situation, we would expect as the temperature rose, the number of ice creams we sold would rise. So you might see a scatter diagram or scatter graph that looks something like this. Okay, and you can see that there's a correlation between the temperature rising and the number of ice creams sold. Okay, this correlation, when there's a sort of relationship that means that as one goes up, the other goes up, this is called a positive correlation. So if you see something looking like this, it's a positive correlation. Now we could have the opposite to that. So let's do another quick set of axes. And this time we would have, let's stick with degrees Celsius to keep it a little bit consistent. And this time degrees Celsius, and let's have number of scarves sold. Now this time, as the temperature goes up, we would expect the number of scarves sold to be lower. So this time we would expect a graph that might look something like this. So as one goes up, the other one is going down. So this is called a negative correlation. Okay, so we've got a positive correlation and a negative correlation. Now let's have a little think. So let's draw our axes again for our third scenario. Let's stick with degrees Celsius, and let's have a number of calculators sold. Now, regardless of how hot it gets, there doesn't seem to be a rush for calculators whether it's very hot, or a rush for calculators if it's very cold. So it could look something like this. And this one, you may have guessed, we've got no correlation. Okay. Now the only other thing to bear in mind is that we also have this concept of strong and weak correlation. And that simply means that the closer the dots are together, the stronger the correlation. So the closer the points are, or the plotted points are, the stronger the correlation. And the more sort of spread out they are, the weaker the correlation. But in an exam, typically they'll just want to make sure that you know that an upward left to right pattern is positive, a downward left to right pattern is negative, and a kind of random pattern means that there's no correlation at all. Okay, so that is correlation in a nutshell. Only other thing I think it's worth mentioning is that you may be asked to draw a line of best fit. So I'm going to do this really quickly. And what you're looking for is you want the same number of marks above the line as on the line and under the line as you possibly can. That one might be a little bit skewed, but this is called your line of best fit. Okay, if they're asking you to estimate something, you will need to draw in that line of best fit to do your estimations. And don't forget, when you are estimating, that you must draw in, and we touched on this, you must draw in how you're doing your estimation so the examiner knows that you not only have drawn your line of best fit, but you also know how to use it. Okay, so that is correlation in a nutshell.